All right, today we're going to talk about solving systems of equations and comparing different methods. So we've talked about 3 different methods for solving a system of equations. We've learned how to graph 2 equations and find the intersection point to find the solution. We've learned to substitute one variable in for the other and solve to find the solution. And we've learned to do elimination, which means you line up the variables, get one to eliminate so that you can solve for the other one and then plug it back in. So all 3 of these will get the same answer if you do it, but sometimes one is easier to do than the other based on the equations. So we're going to compare the methods and see if you can choose which one would be the best method to use. All right, so systems of equations can be solved by graphing, substitution, or elimination. However, there are situations where one method may be more sophisticated than another. Solve the following systems using the graphing, substitution, or elimination method. You may only use each method once. So since we can only use each method once, let's go ahead and look at our equations first before we decide what we're going to do. So for system A, we have x and y by itself on the first equation, so that's good to know. That probably leads more towards graphing or substitution. Let's look at our next equation. This one has coefficients in front of all the variables. So that means graphing is going to be harder because you have to solve for each equation and substitution as well. So B, elimination is probably the best method for that, just to get, clean it up, make it happen a little quicker. And then system C, this one has a y by itself, so this one probably leads more towards graphing or substitution as well. So let's start with the first one, and we'll say that the first one we're going to use the substitution method for this one. All right, so if you remember in substitution, that means you have to have one of the variables equal to something, and that way we can plug it into the other equation. So for system A, I'm going to solve this first equation for x. So all I'm going to do is say x equals, and I'm going to add y to the other side, so y minus 2. And then when x equals this, I can take this and substitute it in for x here. All right, so I'm going to have 7 times my x plus 2y equals negative 5. And then I'm going to go ahead and plug in y minus 2. All right, I'm going to distribute the 7. That's why we need our parentheses there to make sure you distribute. So I've got 7y minus 14 plus 2y equals negative 5. 7 and 2, they're on the same side of the equation, so you combine like terms. And then I bring down my negative 14 and my negative 5. Now I need to add 14 to both sides. And 9y equals 9, and divide by 9. Y equals 1. So 9 divided by 9, y equals 1. All right, so that's part of the equation. So, and again, this one we are using substitution. So let's check that box. All right, so we're doing substitution. So now we got to take the 1 and plug it back in to find x. X equals y minus 2. So x equals y minus 2. So I'm going to take 1 minus 2. 1 minus 2 is negative 1. So my x is negative 1, and my y is positive 1. All right, for system B, we looked and we said that all of these have coefficients. Okay, so it'd be harder to solve for a single variable. So in a case like this, elimination is probably your best method, which means we need to get a number that is the same. We need a positive and a negative here so that we can add these together and have one of the variables eliminate. Since we have 8 and 5 and 3 and 4, I need a number that's going to make these cancel. So if I think 5 and 4, I can make both of those equal to 20 if I multiply the top by 4. And I need to make this negative 20 because 20 and negative 20 will cancel or eliminate. So I'm going to multiply this one by negative 5. All right, so when I do that, I have to multiply the entire equation by that. Okay, so I'm going to have 32x plus 20y equals negative 52. All right, and then the same thing on the bottom equation, I'm multiplying by negative 5. I have to multiply everything by negative 5, and that makes an equivalent equation. So it's just negative 5 times the size of this, and this one would be 4 times the size of that, but it's just an equivalent equation. All right, so 5 times negative 5 times 3 is negative 15x minus 20y equals negative 50. All right, now I've got 17x. Now I have a plus 20 and a minus 20. That one cancels or eliminates. That's exactly what we wanted. And then this is a negative 102. All right, negative 102 divided by 17 gives me negative 6. And then I have to take the negative 6 and I have to plug it back into one of these equations for x. So that was my x. So I'm going to say 3 times negative 6. Negative 6 is my x now. Plus 4y equals 10. So I've got negative 18 plus 4y equals 10. I'm going to add 18 to both sides. And 4y equals 28. So divide by 4, y equals 7. So I've got my x and my y. So a lot of times when you have coefficients for each variable in both equations, elimination is your best method. Again, you can still solve using substitution or graphing, but elimination would be the best method here. All right, now looking at the third system, we've already used substitution and elimination, so this time we're going to need to do graphing because we're supposed to choose one of each for these. All right, so the second equation is easy. All I have to do is solve for y, so I'm going to have y equals, bring the 2x over by subtracting. And then the top one, I have a little bit more work to do. So on the top one, I'm going to have subtract 4x over, so I'm going to have negative 3y equals, if I subtract the 4x over, it moves to the other side, and then I've already got a plus 18, so it's still there. All right, I'm going to divide by negative 3 all the way across, and that leaves y by itself, which is what we want when we graph it. Two negatives make this a positive slope. And 18 divided by negative 3 is negative 6. Once I have my two equations, I can graph it. So you can graph it on an XY coordinate plane. And to save a little time and just make this a little quicker, I'm going to just do this on my calculator. So if I have a TI-84, I have showed you how to graph these and find the solution. So we're going to go to y equals. And when I go to y equals, I'm on my first equation. And my first equation I'm going to type in as negative 2x plus 4. All right, so I'll type in negative 2x and then plus 4. And then I have to take the second equation and put it into my y2. So go down and put in 4/3. Just 4 divided by 3 is 4/3. 4/3 x minus 6. And then I'm going to hit graph. So you can see the first line, and there's the second line, and we want to know where this point is, this point of intersection. So we're going to do second trace, and click on number 5 for intersect. All right, you can see it here. So you always want to click something. We're trying to isolate this point here, so it's to the left of that, so we're going to hit enter. Everything reads from left to right, so you have to click on the left side first, and then you have to go to the right side of the point. So when it says second curve, that means go to the other side of the point, hit enter. It always gives you a guess, but then the next time it says intersection. So just hit enter twice until you find the intersection point. So 3, -2 is your intersection here. All right, and for each of these, you can also go back in and plug these in and check them. So you can plug your 3 in here. So -2 times 3 is -6. -6 plus 4 is -2. So that works for that one. And then 4/3 of 3. 4/3 of 3 is 4. 4 minus 6 is -2. So it works for that one as well. You can also do that with the other 2 equations with substitution and elimination. All right, I hope this helps you to see that although you can use multiple methods to get the same answer, sometimes one method would work better than another method.